Today we're going to be talking about solving literal equations. So we're going to start first with our vocabulary. A literal equation is just an equation with two or more variables. So you're not going to just see one you're solving for, you're going to see multiples. Now, literal equations can actually be pretty intimidating. It's not uncommon that students feel like they don't know what they're doing as soon as we change a number to be a variable. But I will always want you to relate it back to equations that we've already learned how to solve. So to do this, we're going to actually look at this first problem. It says, given the problem ax plus b equals c, it wants me to solve for x. Now, that's pretty intimidating because all I see is variables, but I'm going to basically highlight the variable it wants me to solve for. In this case, it says solve for x. So I'm going to highlight the x. And then that kind of tells me that I'm going to change every other variable to be a number. So for example, I could make that a become a 5. I could make that b become a 3. And I can make that c become a 13. And you should see the similarities now of how this equation looks like something we've already been doing. So I'm going to refresh your memory. If we had the equation 5x plus 3 equals 13, remember the first thing I'm going to undo is that addition of 3, and I would do that by the inverse of subtracting 3 from both sides. 3 minus 3 would give me 0. I would drop down that 5x. 13 minus 3 would give me 10. And then I would undo the multiplication by dividing by 5. And I'm able to get that x equals 2. Now, I told you that it's pretty much the same thing as this new literal equation, except that I have now converted the 5 to be an a, x stayed the same. I made the 3 become a b, and I made the 13 become a c. However, I'm going to do the exact same process. So on the first problem, I subtracted 3 from both sides. Since 3 is now b, I'm going to actually subtract b from both sides. Now here's where it gets a little bit different. B minus b gives me 0, still goes away. I can still drop down ax equals, but can I take b away from c if those are not like terms? The answer to that is no. So I'm just going to write it as c minus b. I can't do anything else with that. Then remember, after I subtracted 3 from both sides, I undid the multiplication of 5. In this case, it's being multiplied by a. So I'm going to have to undo the multiplication of a by dividing by a. Now, you can do this to each individual variable, which would then give me x must be c divided by a minus b divided by a. And I can't actually do that, so I can leave it just like that. Or you can actually do it over the entire c minus b. And you can write it like this: c minus b all over a. Both of those are mathematically correct. Now, I am going to tell you that these problems take a lot of practice for you to feel confident with them. So we're going to just hammer it home and do as many as we can. Okay? I'm going to first highlight the variable that it's asking me to solve for. So in this case, it's asking me to solve for x. I'm going to highlight that. If I get confused as to what I'm trying to do, I can then change the other variables to just numbers so that I can see what I'm actually going to do. If I had x plus 2 equals 6, I would have to undo the addition of 2 by subtracting by 2. So I'm actually going to undo the addition of m by subtracting m from both sides. M minus m will go away, it'll equal 0. Drop down my x. Remember, I cannot do t minus m because those are not like terms, so I'm just going to write them side by side. Okay, number 2, it still wants me to find x. So again, if I needed to, I could rewrite this, changing all other variables to a number. The only other variable I have is k, so I'm going to change that to a 12. If I had that problem, I would have to undo the multiplication of 4. Same thing's actually going to be true for this equation, the literal equation, because I'm trying to get x by itself. So I have to undo the multiplication of 4 so that x will be all alone. Now remember, what I do to one side, I do to the other. And I can just leave this as k divided by 4 because I don't know what that is. All right, number 3, again, I'm trying to isolate x. If I needed to, I could change every other variable to a different number. So I'm going to change v, let's just say 10, and I'm going to change L to be 20. If that was my problem, I would have to undo the subtraction of 10 by adding 10. So that means I'm going to undo the subtraction of v and add v to both sides. Negative v plus v will give me 0, so that will go away. I'm going to drop down my negative 2x equals, now remember, I cannot combine L and v, so I'm just going to write them side by side, L plus v. Now I have to undo the multiplication of negative 2, so I'm going to divide by negative 2. Remember, I can do that to each individual piece. That would give me x equals a negative L divided by 2 minus v divided by 2. And I just bring that sign out front of that fraction. Or I can divide it by the entire problem. So that would leave me L plus v divided by negative 2. Both of those would be okay. All right, number 4, this section wants me to solve for y. So I'm trying to get y by itself. That means if needed, I could change every other variable to be a number. I'm going to change p to be 4. If I was solving that equation, I would have to multiply both sides by 2 to undo the division. Well, that's still going to be true, so I'm going to multiply both sides by 2. That will give me y equals, and remember how I write p times 2 is actually 2p. I always put the number in front of the variable. All right, number 5. Again, I'm trying to isolate the y, so that means I'm going to have to get rid of the z and the 4. If I need to know what to do, I'm going to change the other variables to a number. So I'm going to change that z. Let's say it's a 5, and I'm going to say that n is a 6. If I had this problem, remember this is a unique problem. I cannot subtract 4. You can tell because that 5 is in the way. So first what I'm going to have to do is undo the division of 5. Or in our literal equations case, undo the division of z. So I'm going to multiply both sides by z. That's going to give me y plus 4 equals, and remember n times z, I can just push those together to get nz. Now I can undo the addition of 4 by subtracting 4 from both sides. 4 minus 4 is 0, so I get y equals, I cannot actually do this, so I'm just going to write them side by side, nz minus 4. All right, now number 6, really important problem. I want you to put like a star next to it. You're going to see a lot of these problems throughout Algebra 1. This equation, how it is seen now, is actually called linear standard form. And we're going to solve for y. In other words, we're going to get y by itself, and that's going to be actually converting to a different linear form. First, I'm going to rewrite this equation, replacing the x with a number. So if x was, let's say, 4 plus y equals 10. If I want to get y by itself, remember I have to undo the addition of 4. So I'm going to undo the addition of x. It's positive, so I subtract x. X minus X is 0, so that goes away. I can drop down Y, and then I can write this as 10 minus X. You could actually also flip this. You can put the negative X in the front and the positive 10 in the back. And maybe you'll notice that this is something you recognize from middle school. It is called slope-intercept form. In other words, you may remember it as y equals mx plus b. These problems are extremely important that you understand and are able to do it because we do it so often in Algebra 1. So we're going to do several more just like it. All right, so looking at number 7, I'm trying to isolate the y. So I need to move that 3x. If in this case I got confused of what to do, I could just drop that x and act like it's just a 3. If it's just a 3, I'm still going to get rid of it. It's a positive 3 or positive 3x, so I have to move it by subtracting, just like I would up there. I do not divide because I'm not trying to split apart the 3 and the x. I'm just trying to move that entire term to the other side of the equal sign. 3x minus 3x is 0, so that goes away. I get y. I'm going to say negative 7 minus 3x. Again, if you wanted to reorder, you could. You do not have to. I would put negative 3x in the front and negative 7 in the back. You only are going to divide. I'm going to go back to this 3x. You only divide if the variable that I'm trying to isolate has a number or a coefficient in front of it. All right, number 8, I'm still trying to isolate my y. I could rewrite this with no x just to help me see what I need to do next. If I had that problem, I would have to add 2 to the other side. So in this case, I'm going to add 2x to the other side. Again, I'm not going to divide because I'm not trying to split apart the 2 and the x. I'm trying to move the entire term to the right-hand side. Negative 2x plus 2x gives me 0, so that goes away. Do not forget to drop down the negative sign with the y, and I have 5 plus 2x. Now this is really important. I can never leave it as negative y equals, so I have to undo that. Remember, that's a negative 1y. If it was a negative 2y, I would divide by negative 2. So since it's a negative 1y, I'm going to divide everything by negative 1. Ultimately, all that does is change all of the signs. So 5 becomes negative and 2x becomes negative. Again, you can leave it like this, or you can rewrite it with the negative 2x in the front and the minus 5 in the back. Number 9, I'm trying to isolate the y. Again, if you need to know what to do, you can change the x to be a number. I'm going to say it's 4. In this case, I would have to undo the 4. So in my problem, I'm going to undo the x. It's a positive x, so I'm going to subtract x. X minus x gives me 0, so it goes away. Drop down my 3y, and I have 5 minus x. Now I have to divide because I have a coefficient of y. It's a 3y, so it's being multiplied, so I need to divide by 3. And remember, I do it to every term. This is an example of where I would want to separate it out because that way I can actually see my slope and my y-intercept. Again, this has a 1 in front. If that confuses you at all, you can write it as 1/3. So you might want to move this to the front and say negative 1/3 x, and this is a positive 5/3. Number 10, I'm trying to isolate y, so I'm going to change that 2x to just 2. I'm going to drop the x off of it so I can see what to do. In this case, I'd have to move the 2 by subtracting, so I'm actually going to move the 2x by subtracting. 2x minus 2x goes to 0. I can drop down 5y. Remember, I cannot do 10 minus 2x since they're not like terms, so I'm just going to write them side by side. Now I have to undo the multiplication of 5 by dividing each term by 5. Again, you can rewrite this with your negative 2/5 x in the front, and your positive 10 divided by 5 actually can simplify to a positive 2 in the back. Number 11, I'm trying to isolate the y. Again, I can drop that x just to help me see what I need to do. I would have to add 4 to both sides, so in this case, I'm going to add 4x to both sides. Negative 4x plus 4x gives me 0, so that goes away. Drop down the negative 2y. Remember, I can't combine these. They're not like terms, so I'm just writing 8 plus 4x. Now I need to undo the multiplication of negative 2, so I'm going to divide each term by negative 2. Again, I can reorder if I'd like. 4 divided by negative 2, that's going to give me a negative 2x in the front. You do want to simplify that fraction if you can. And then 8 divided by negative 2 gives me a negative 4 in the back. Number 12, I'm trying to isolate this y. Again, if needed, I can change the other variables to a number. So I'm going to say my b is actually a 2, and I'm going to say my mx is 10. So if I'm going to undo this, I would add 2 to each side. So in this case, I'm going to add b to each side. So that means negative b plus b would equal 0. I'm left with y. I can't combine those because they're not like terms, so I just get mx plus b, which is our slope-intercept form. Now we are almost done, but I want to show you 2 really common literal equations that we see a lot. And that first one is perimeter of a rectangle. You're going to see this a ton. So perimeter of a rectangle can be found by the equation P equals 2L plus 2W. It wants me to actually solve this equation for W. So I'm going to highlight that W. It wants me to get that alone. Again, if needed, I can change those other variables to numbers. So I'm going to say P is 10. I'm going to drop the L from 2L plus 2W. Now, if I had that equation, I would have to move this 2 to the other side. So I'm actually going to have to, if it's a positive 2L, I'm going to subtract 2L. I can't do P minus 2L because they're not like terms, so I'm just going to write them side by side. 2L minus 2L goes away, it equals 0. And I drop down my 2W. Now I'd have to undo my multiplication of 2, and I would divide by 2. Again, you can do it to each individual piece. If I do that, I end up with P divided by 2 minus, these 2's would go away, and I'd get L equals W. Again, if you wanted, you can do your P minus 2L divided by 2, the whole thing all at once. So that would look like this. You could just literally leave it as this. Either one of those is completely acceptable. Now, last problem, I want to solve this one for M. So I'm trying to get M alone. Remember, M is actually being multiplied by the parentheses, right? So I'm going to actually divide by the entire set of parentheses all at once. And what I do to one side, I have to do to the other. So that would have that go away, it would equal 0, and I'm left with y minus y1 over x minus x1 equals m. This should look really familiar to your slope formula you learned in middle school. If you remember, that one was written as m equals y2 minus y1 over x2 minus x1.